All right. Right. Let's start. I guess I'm audible. Audible, right? Anyone? Am I audible? Okay. Right. Let's start. I checked from my device. It's fine. Okay then. Okay. It's working now. Right. Right. Yes. Okay. So good evening again. We'll start. So today this marks the 7th day of our STO discussions, right? So far we have discussed linear motion, projectile motion, vectors, equilibrium of forces, what else? Surface tension, right? So those are the lessons we discussed so far, right? And today I'm going to discuss center of gravity, right? I'm going to discuss center of gravity. And since we have finished viscosity and elasticity in the reverse class, I'll be soon allocating 2 days for viscosity and elasticity as well, right? Yeah, and in the regular theory class, thermal parts are almost finished. So for thermal also, I'll be allocating few sessions. Right now here, mainly I'm focusing on mechanics parts, right? So likewise, we'll be allocating sessions, right? We'll be allocating sessions. You can get all updates through all the channels like WhatsApp, Telegram, or YouTube channels about which lesson goes on a particular day on the particular week, right? On the certain week, right? And you can join and check your level of understanding of that particular lesson, right? Check your level of understanding. That's the thing, because now if you are 100% okay with past paper questions, right, which means you have gained a certain level, the required level at the exam, right? If you are doing past papers, if you are tackling past papers without any hassle, right, that's what it should be, that's how it should be, right? Okay, so that's the purpose of these discussions, and we are on the 7th day today. We are on the 7th day today, right? I think it is shared in all groups, right? Isn't it? I think the live is shared in all groups, and by now we have downloaded the questions as well. Questions are available in the Telegram, right? Telegram channel. You can navigate there using the pin message here in the live chat, right? Or it's in the description of the video. Oh, I think the link is put in all the groups as well, groups and channels. Yeah. Okay then. Right. Then without further ado, we'll start. Right. Without further ado, we'll start. Right. Let me share my screen. All right. Screen is visible, right? Visible now? Let's go to the discussion. Okay. Right. First one. A thin plate of irregular shape is suspended freely by cord from a point as shown in the figure. Figure 1. Next, the plate is suspended freely from another point B as shown in the figure 2. The center of gravity of the plate is most likely to be found at. Right. The main theory part behind this is, we know if an object is suspended by a single point, right? If an object is suspended by a single point, let me draw an irregular shape, something like this. If an object is suspended by a single point, right? Always, it comes to an equilibrium mass. Its center of gravity and suspension point are coming to the vertical line, same vertical line, right? So always now, if I suspend this using a single point, see, this comes to the equilibrium mass. suspension point and the center of gravity of the object are at the same vertical line. That's the same theory. That's the theory which is going to apply here, right? Now, in figure 1, if you mark this vertical line, right, it should be going through A dash, right? I think, I mean, it seems due to a typing mistake, A dash is a little bit kind of displaced, right? It should be exactly below A as a vertical line to get that idea properly, right? Like this. Now, then we can say on this line we have center of gravity, right? COG, center of gravity, is on this line. It is on this line, right? Let me draw this like this. Now, the line which connects A dash has center of gravity on it, and if it is suspended by B, right? The vertical line which goes through B, like this, the vertical line which goes through B is also center of gravity, right? Right? On the vertical line which goes through B, like this. On this vertical line which goes through B, right? Again, center of gravity should be located, because always we know center of gravity and suspension point should be vertical. It should be vertical. Then the intersection point of these two, if you have two lines, right? If you have two lines, intersection point of these two should be the center of gravity, right? Yes. It is close to S, no? It is close to S. Close to S. See how easy the question is, right? Connect these two lines, and that's the point where the center of gravity is. Right. Second one. The diagram given is a cross section of a toy. Cross section of a toy placed on a horizontal table, which always returns to upright vertical position when released. The center of gravity of the toy is most likely to be at, right? So we know reaction acts from this surface, no? Reaction acts from this surface, right? Reaction acts from this surface, and that's a hemispherical kind of a surface. This is hemispherical. This part is hemispherical, which means when this rotates, this is how these reactions are going to act. This is how these reactions are going to act. This is how these reactions are going to act, right? So if this returns back to its initial position, right? Back to its initial position, which means it is always better to have center of gravity somewhere close to ground, because then it creates that counter torque. Counter torque, like this. Counter torque means a counter force moment to take it back to the initial position, to take it back to the vertical position, upright position, right? Then it should be close to ground. It should be as much as close to ground. It should be as much as close to ground, right? But it cannot be taken to E. Never. It's never can be taken to E, because there is a mass which is above E. If there is a mass above E, then it cannot be taken to E. Then closest point to ground is D, no? So it should be D. Closest point to ground is D. It should be D. Got it? Simple. Right? Next. 3. A person bends over and touches his toes as shown in the figure. The center of gravity of the person is most likely to be found at. Right? So one thing is, center of gravity of a human being. Center of gravity of a human being is at, center of gravity of a human. Center of gravity of a human is at the hip, right? Center of gravity of a human is at hip. When he is standing, when a person is standing, right? That is at the hip. Now, when we bend forward, center of gravity displaces us forward, right? Now, this is the supporter now. Supporter means is the part which supports the reaction from the floor. This is called the supporter, right? And center of gravity should be inside supporter. Should be inside supporter. Inside supporter. And direction of motion is this one bends to the, displaces to the right while bending downwards. Then it should be a motion, displacement of the center of gravity to the right and downwards. To the right and downwards means that is B, right? To the right and downwards, that is B. To the right and downwards at the same time, that is B, right? Like that. 4. 4 is a kind of a good one. the coordinates of the center of gravity of a uniform sheet of cardboard shown in the figure are x0 and y0. Right, x0 and y0. The cardboard is now folded along OP as shown in figure B. The center of gravity of the XY folded cardboard has coordinates where? Has coordinates where? Right. Now, if we argue about this, it has one symmetric line. No, this is a symmetric line for the first one. Right, for the first one, this is a symmetric line. Then, with respect to this line, this is the center line, and these two are the center lines of these two. See, now when we argue using center lines, that is kind of easier. These two are the center lines of these two, right? Now, with respect to this center line, it should be a little bit downwards because there is a part of a mass that is below this center line, no? And with respect to this vertical center line of the other one, there is another mass here. Then it should be to the left of this point. Then to satisfy both, center of gravity of this one is going to be somewhere here. Center of gravity of this given plate is going to be given cardboard is going to be somewhere here. Center of gravity of the given cardboard. Right, now it is folded. See what's happening when folded, right? See, simple. Now before that, let's get an idea about x0 and y0. Now y0 has been this and x0 has been this. These two are x0 and y0 according to this given figure. These two are x0 and y0 according to this given figure. Right, now this mass is taken to this axis. Then compared to this line, again if I compare, listen, compared to this line, mass is coming towards this left side, no? More mass is coming towards the left side, isn't it? More mass is spreading towards the left hand side. This mass is coming to this position, no? Then when this mass comes to here, right, according to this line, it comes downwards. According to this line, right? This comes downwards. Let me use another color. According to this line, with respect to this line, it is coming downwards, right? Downwards, which means from the previous center of gravity, it should come downwards from the previous center of gravity. And with respect to this line, it is coming from left to right, right? With respect to this line, that is coming from left to right, which means from this position, it should be shifting to right as well. Then from this initial position, it is shifting right and shifting down. Shifting right. Shifting right means compare with x0. If there is shifting right, nu x should be greater than x0, no? If there is shifting right, nu x should be greater than x0. If there is shifting down, y should be less than y0, no? Right? That's it. Right? Simple argument. Then x is greater than x0, y is less than y0, it's 4. Right? 5. When a H-shaped body shown in the figure is hung from point B, it hangs with point D directly below B. Again, the same theory as before, right? Then B and D, if you connect B and D, center of gravity should be on this line, no? If you connect B and D like this, center of gravity should be on this line, right? Then when the body is hung from point D, it hangs so that point C is directly down E. Point E, then E and C, connect E and C. Connect E and C. Right. Now, the center of gravity is most likely to be at. It is most likely to be at the point where both these lines are intersected, right? Because if there is hung from one point, a simple theory, always the hanging point and center of gravity becomes vertical, right? So hanging point and center of gravity. Then center of gravity should satisfy both of these lines. Both of the lines, then it is close to S, right? It is close to S. So it is S, close to S. It is S. Simple. 6. The water H2O molecule has the shape shown in the figure. The center of gravity of the molecule is most likely to be found at, right? Okay, it is symmetric, then it is on the symmetric line. since that is symmetric, right? It is on the symmetric line. And if you compare the molar masses about oxygen and hydrogen, oxygen is 16, right? Oxygen is 16, and 16 one oxygen, right? Oxygen is 8, and hydrogen is 1, 2. Then it's like a mass of 2 is here, a mass of 8 is here. So it should be more close to oxygen, right? More close to oxygen. Center line goes somewhere here, no? Then more close to oxygen, that is S. More close to oxygen, that is S, right? Next, a uniform wire is bent as shown in the figure. The center of gravity of the whole wire is most likely to be found at, right? So we know it has one symmetric line here, then that is on the symmetric line, then you better draw the center line of this. What about the center line now? Center line is somewhere around this, right? Center line. Then with respect to center line, we can compare. See, now from this center line, right, to this side we have only one rod, which means like 1 mg, and here we have 2 rods like mg and mg, right? Then as a total, it is like 2 mg this side and only mg this side. Then it should be shifting towards this side, no? Should be shifting towards the heavier side below. Then it is not as close to D, right? It should be somewhere around C. It is coming downwards from that center position. Again, pahal position. That's the logic, right? 8. The center of gravity of the object is most likely to be at. Okay. Now, first thing is, this part is symmetric. This part, the part consists of these 6 parts are symmetric, no? Isn't it? That is symmetric from this line, and that is also symmetric from this line, right? In terms of the masses, that is symmetric. Then the other part, which is remaining to compare is this one, right? This mass is added below this center line, no? Below this one. Then from this center position, it should shift below. And this mass is added to the left compared to the vertical line. To the left. Then it is shifting to left. Then from this position, it should shift below, shift down, and left. Then only position comes is B. Simple arguments. 9. The frame shown in the figure is made from a uniform wire. The center of gravity of the frame is most likely to be at. Okay. Right. Again, we can get an idea with the center line. Now, this is like the center line, no? This is like the center line. Now, with respect to this center line, there is no mass located here. This weight is on this line. And weight of all of them 3, right? If this is mg, right? Now from this position, it's like 3 mg, no? Because three rods are acting, 3 mg. Then it should be shifting more towards this side. Then should be D. Shifting more towards the 3 mg side. Should be D. 10. A uniform circular plate of radius 2r has a circular hole of radius r cut out of it as shown in the figure. The center of gravity of the plate with the hole is most likely to be found at, right? Then initially we know if this part was filled, center of gravity is at T, right? If a weight is removed from this side, right side, center of gravity shift to the left side. Right? Now we have 2 points as D and A, right? So it cannot be shifted to a further point as A because some mass is still here. Some mass is still here. So probably it should be D. It should be D, right? If you need more verification, right? If you need more verification, since data are given, you can do a calculation for this if needed, like this, right? So if needed, you can do a calculation like this, right? This weight goes, this is a plate, right? Plate. Then we are using areas, no? Then phi r squared means 2r squared rho g, and weight of this one is phi r squared rho g. Then resultant is going to be somewhere here. This is 4 phi r squared, then 3 phi r squared rho g. Apply force dividing ratios for this one, right? If this is center of gravity, considering this as center of gravity, right? Then from here to here, we know this is r. Let's consider this as x. Let's consider this as x. Let's consider this as x. Then force dividing ratios. We can find x as total distance is x plus r over resultant 4 phi r squared rho g into, if you need x, multiply it by the not connected one, phi r squared rho g. Phi r squared rho g to phi r squared rho g cancels. Then 4x equals x plus r, right? Simplify this. It says 3x equals r, then x equals r over 3. X equals r over 3, which means this is only r over 3 distance from here. This is only r over 3 distance from, this is only r over 3 distance from this center, right? Then which means very close to center, right? So that's a verification, that is D, that it is D, right? 11. Figure shows a piece of metal in the shape of a letter E cut from a uniform sheet. The center of gravity is most likely to be found at, right? Now, if I separate this from here, and think of these remaining 3 parts here, these 3, its center of gravity should be at the center, no? Because they are uniform, then their center of gravity should be on this center line. They should be on this center line, on the center line, like somewhere like D, right? Somewhere like D. Now, with respect to that, another mass is added here, right? Another mass is added here. Then from D, it should be shifting towards the other side, right? Shifting towards the left side, right? It cannot be as close as B because this is more or less the same mass added compared to this one. And if I compare these values, my values check right? If this is 1 is M, it is like 3 mgx from here and only mgx from here, right? Then center of gravity should be much closer to D, much closer to 3 mg, then it is C. It should be closer to 3 mg, no? Arne? Should be C, right? 12. Identical laminate cut into the uniform into the form of letter E are pivoted vertically at X. If G is the center of gravity of the laminate, which of the states shown in the figure are stable equilibrium positions? What is stable? Stable means center of gravity or acting line of weight. Center of gravity or acting line of weight should be inside supporter, right? It should be inside supporter. And stable means it won't change the position over time. Stable means that its position is stable over time, right? Stable means position is unchanged over time. Its position should be unchanged over time, right? Okay, now if we check the first one, X and G, they are on the same vertical line, right? It is not going to rotate either, so it is a stable position, right? And if we compare the second one, X is here, G is upwards, G is above, which means he is going to rotate this way. This might rotate, so this is not an stable position, right? In this case, X and G they are vertical, that is a stable position. In this case, both G and X are on the same point, then this is rotatable around this, no? That is a neutral equilibrium. That is neutral. Then only A and C. Right? If that is stable, its position should be persistent. It should be a persistent, consistent over time. Right? Should be same. Should be same over time. Position should be same over time. Same in the sense remain unchanged. 13. A frame is made by joining should be 3. There are 3. Joining 3 uniform rods P, Q, and R having identical geometrical dimensions as shown in the figure. Rods P and R are of the same mass, but the rod Q is twice as heavy as P or R. Okay. Then if I mark center of gravity of these two, right? It is like 2 mg, no? If one is m, right? Now Q is 2m, then from its center of gravity, another 2 mg should act like this, right? This is the force frame, right? These are the forces acting. These are the forces acting. When the frame is suspended freely from point X, the equilibrium position is most likely to be, right? Listen, now if you get an idea about the center of gravity, since this is a symmetric object, center of gravity should be on the symmetric line. Should be on the symmetric line. And these two forces are 2 mg and 2 mg, you know, which means center of gravity is coming to the exact center of these two, right? Exact center of these two, right? This is the position. I have identified now. I have identified the center of gravity. This should be the position. This is a probable point, right? Now, we know if this is suspended, suspension point and center of gravity should be vertical. So you can connect these lines and see in which case it is coming to our anticipated point. We know center of gravity should be on this symmetric line because all the diagrams are symmetric, no? Should be on the symmetric line. These are the symmetric lines, right? These are the symmetric lines, right? They should be on the symmetric line. They should be on the symmetric line. Go there. Okay, this one. This is the symmetric line, right? And here also, likewise, you can draw these symmetric lines to get a better idea. Right now, vertical lines are them. See, these are the vertical lines. Now, if I connect the vertical line, see, now this center of gravity is going to be somewhere here. Impossible to have. And if you connect this center of gravity is going to be, right? See, if you connect this one, this center of gravity is going to be somewhere here. It's possible. It's possible. And in this case, somewhere above that point, right? So in this case, it's still above. It is very above. Then it is close to 2, right? Right? It is close to 2, this one. Then should be 2. Right? And I think this line is a little bit, this should be a little bit above this. That's a symmetric line, something like this. Somewhere here. So it is just above. Right? So it should be 2. So likewise, draw it and identify the center of gravity, because here I have identified this center of gravity must be here. I have identified this center of gravity must be here. Then once you connect these vertical lines also, vertical line and symmetric line, the intersection point should be center of gravity, no? That's a logic. Right? Next. About 14, there was a small mistake in the diagram. Let me explain it. 3 identical uniform books are placed on each other as shown in the figure. The center of gravity of the set of books is most likely to be found at, right? The mistake was point B should be given exactly above this edge, right? Point B should be given exactly above the edge, right? So we know this is in a neutral equilibrium. Right? Right? If there is elongated to the outside as much as possible, right? Which means that is in a neutral equilibrium. At neutral equilibrium, center of gravity should be at the edge of the supporter. Now supporter surface is from here to here. Then at the edge of the supporter means it is going to be B. right? You can check with the diagram given in the original paper, right? In the original paper, the exact correct diagram is there. I think in some of the Pasindu books, that diagram is not properly drawn in some of the Pasindu books, right? Okay. 15. A toy is made from a child figure holding a section of a thin ring which carries two identical heavy metal balls. Is made from a thin metal sheet as shown in the figure. If the toy can be balanced in stable equilibrium as shown in the figure, the toy can be balanced in the stable equilibrium from the toe of the child. That's an important one, toe of the child. So from here, which means from the toe, most probably the center of gravity of the system can be found to close a point. If there is balance by the toe, center of gravity should be at the toe because reaction acts from the toe. No? Then counterbalance the reaction with mg. To counterbalance reaction with mg, center of gravity should be at toe. To counterbalance that reaction with mg, center of gravity should be at toe. Toe means T. Right? For 15, it's 5. For 15, it's 5. 16, water droplets, it should be drop. Water droplets drop at a constant rate from a tap as shown in the figure. As shown in the figure. The center of gravity of the system of drops in the air is most likely to be found at. Okay. Now let's draw a center line first. Let's draw a center line first. From here to here, if I compare, center line is somewhere here, no? Right? Roughly, center line is somewhere here. Roughly, center line is somewhere here. Right? Now, with respect to that center line, look at here, with respect to that center line, there are two droplets here and three droplets above. Then center of gravity should be three droplets above. Three droplets above. Three droplets above. Then center of gravity should be, give me 1 second, I'm getting a urgent call. 1 second. Sorry about that. Sorry about that. I got a urgent call. Right. See, what I was explaining was, now I'm audible, right? What I was explaining was, now from the center line, there are three drops above the center line. Three drops above, no? Audible, right? Okay. There are three drops above the center line, which means center of gravity should be more towards the upside, no? More towards the upper side, no? Then from the center line, it should be more towards the upper side. More towards the upper side, it is probably R. It is R. Not as close as Q. Q is point and Q is very close to the top, right? Q is very close to the top. So it should be R. Probably it is R. 17. 17. Two identical uniform bricks of length L are stuck without being toppled. Not bring, it should be without being, typing errors. Without being toppled on a table as shown in the figure. The respective maximum possible values for L1 and L2. Right? Listen, this is an important argument we have in center of gravity. if you are asked about a maximum, maximums are determined by the neutral equilibrium. Maximums are determined by the neutral equilibrium. Why? Neutral equilibrium is the very last point that the object can be kept at equilibrium. No, neutral means very last point the object can be kept at equilibrium. That's the last point. Then maximizing is done by the neutral equilibrium, because just after neutral point the system is going to fall, going to topple, going to collapse. Then we are doing this to the neutral point. At the neutral equilibrium, center of gravity and supporter should be at the center of gravity should be at the edge of the supporter. Center of gravity should be at the edge of the supporter. Then start balancing from the top one. I discussed in the theory class, right? Start balancing from the top one. Make a top pega. Always you have to start from the top and balance it to the neutral equilibrium. Then center of gravity of this should be at the edge of the supporter, like this. Center of gravity of this should be at the edge of the supporter. Support of the first one is this one. Then it is balanced when this L1 has to be L over 2. No need to do any calculations. That is L over 2. That is L over 2. Right? Then when it comes to second one, look at here. This is how second one is balanced. When you are coming to the second one, at the edge of the second one, there is a weight acting already. From the center of gravity of the second one, its weight also acts like this. From the center of gravity of the second one, its weight also acts. And from the edge, because of the top one, this mg also acts. Now, center of gravity of both of them, both these forces has to be here in order to balance this. Then this is 2 mg in a total, as total, 2 mg as total. Then L2 should be apply force dividing ratios. L2 equals force dividing ratios කියලා කියන්නේ total distance between these two. Total distance. Still L over 2, no? Capital L over 2 over addition of forces 2 mg. This is a proved theory. We proved in the class and we did all questions using this. 2 mg into, if you need this side, into not connected force mg. Mg to mg cancels. L over 2 means L over 4. Then L over 2 and L over 4. Answer 1. That's a small calculation. I think we made a calculation after a long time, right? Most of the questions were guessings of center of gravity, arguments, guessings, right? So we did a calculation after a long time. A simple calculation, right? Arnev, a simple calculation. Next, 18. Figure shows a thin uniform L-shaped metal sheet. The center of gravity of the sheet is most likely to be found at. Okay. Now, if I separate this sheet from here, this line is also given. Center of that line is at B, no? Then center of gravity of this part is at here, right? Center of gravity of this part is at here. And with respect to this side, center of gravity of that part is here at D, no? With respect to this side, and with respect to this side. Then center of gravity of the combination should be on this line. Center of gravity of the combination should be on this line, which connects B and D, right? Which connects B and D. It should be on the line. Now we are done. Only point which is given on that line is C. Then it must be C. Got it? Simple argument. So as long as you know these theories properly, it is never going to be a hard question. It is never going to be a difficult question. And center of gravity is a definite question you are getting in the MCQs, right? So you can secure 1 mark if you know center of gravity. 1 out of 50. 1 by 1. You have to collect marks 1 by 1 from 50 in the MCQ, right? 19. A pencil is held vertical on its tip on a frictionless table as shown in the figure. When it is allowed to fall freely towards the plus x direction, the path of the center of gravity of the pencil is best represented by, right? Listen, that is on a frictionless table. This is very important. Nah? That is on a frictionless table. Now, center of gravity is here. Center of gravity is here. If there is on a frictionless table, this is the impact. Listen. If there is on a frictionless table, there's no any friction at the tip. If there's no any friction at the tip, right? If there's no any friction at the tip, friction won't be held or won't be what we call counteract, the motion won't be counteract by friction. Then it is very free to move. It is totally free, 100% free to move the tip, right? Which means when it is free to move, right, it won't create any force moment. Then no force moment, no force moment, no force moment, no force moment. Now, if it has enough friction, then this kind of a force moment can be created. But if there's no friction here, no one to hold this point. There's no one to hold this point. This slips, and it won't create any force moment, which means center of gravity is going to fall down without any force moment. It's going to fall down without any force moment. Then it must be vertical. It must be vertical. If there is falling without any force moment, it must be vertical, right? It is going to be vertical. It must be vertical. It is 5. Make the point. If there is frictionless, no force moment, then it must fall vertically downwards. It must fall vertically downwards, right? 20. A rod XY rests between two smooth boards. PQ and QR kept inclined to the horizontal as shown in the figure. Angle PQR is 90. It is given, and the surfaces of boards are normal to the plane of the paper. The center of gravity of the rod is most likely to be situated at that point. Okay. We know if there is an object which is in equilibrium under three non-parallel forces. In three non-parallel forces. All these three forces should be concentric. They should be concentric. What does that mean? Concentric means goes through same point. Goes through same point. Then you can mark these reactions. See, this reaction is perpendicular to this surface, no? This reaction is perpendicular to this surface. Mark this reaction, right? And this reaction is also perpendicular to this surface. May reaction at mark karan like this. See, this reaction is also perpendicular to this surface, right? Now let's remove the ruler, right? Now these two are the two reactions here. Say Rx and Ry. These two are the two reactions here. Now third force, third force is mg. It should also go through. See, it should also go through the same point like this. Then this is how mg should act. This is how mg should act, right? Then what is the point? It is most likely to be, it is D. If mg acts here, that is D. Do this construction. That's a construction. Do this construction, right? We have to do the construction. Right? 21. A uniform thin wire. 21. Right. A uniform thin wire is bent into wire frame with two ends, X and Y, kept open dash shown in the figure. The center of gravity of the wire frame is most likely to be at the point. Okay. Now, let's argue this way. I'm going to isolate these wires. Look at here. I'm going to isolate these wires. If I compare this one, this wire with this. If I compare these two, let's compare it with respect to this center line. Let's compare with respect to this center line, right? Now, if I compare with respect to that center line, at the right side, the length of the wire is only this much. Look at here. The length of the wire is only this much from here. And here, there is a length of this. Then length of the wire at the right side is higher, no? Which means, compared to left side, because left side is length. Compared to left side, length of the wire at the right side is higher. Which means, it should shift to the right from this position, no? Center of gravity should shift to right from this position. Can't we do the same considering this this axis as well? Center axis which goes through this axis. Right? Compared to this axis, more weight is at the top side. Then it should move upwards as well. Right upwards and right and up with respect to my lines. Right and up means it should be D. Should be D. One easily order answer ganna puluwa. should be D. It should be D. Right? Then 22. About 22. Again, there's a small mistake in the diagram. Here also there should be two masses. One mass here, and there should be another mass here. This is the complete diagram. Right? Then only it comes to 11 masses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's how it should be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 8, 9, 11, 12. Oh, wait. 1, 2, 3, 4, 5, 6, 7, 11. It's 11. Right. Now, center of gravity is most likely to be at. Okay. Each of mass simple name. Identical, no? Identical. Each mass is simple name. Right. Now, see, look at here. These two masses, this one to this one, and this one to this one, they are symmetrically distributed, no? Since they are symmetrically distributed, their center of gravity is at O, right? And similarly, these two masses are also, these pairs are symmetrically distributed. Then their center of gravity is also at the same point. Then from this same point, 8 mg acts according to that, because 8 masses are there. 8 near 1, 2, 3, 4. Yeah. 8 masses are here, then 8 mg acts from here. 8 mg acts from here. Not 8 mg, 9 mg. Ne? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. 9 mg acts from here because there is another mass at the center as well. Center then altogether 9 mg acts here. Center of gravity of all these ones are at the center because they are symmetric. They are symmetrically distributed, symmetrically spread, symmetrically distributed. Right? Then that is at the center. Now what is remaining? Only these two. Let me use a different color. Only these two. Only these two. Center of gravity of these two should be on this line, isn't it? Center of gravity of these two should be on this line. Then it should be somewhere here. Symmetric, no? It is only 2 mg. It is only 2 mg. Then 2 mg and 9 mg. Center of gravity should be more towards 9 mg. 9 mg is like more than 4 times of 2 mg. Then it should be more towards 9 mg side. Then the only given point is point C. Should be C. Right? So likewise, you should be able to like see the symmetricness and everything. Symmetricness plays a role. Symmetricness plays a role. Right? Next. 23. The combined object illustrated in the figure is formed by joining four metallic rings A, B, C, and D of radii R, 2R, 2R, and 3R. Okay, R, 2R, 2R, and 3R, respectively, made out of the same uniform wire. The distance of the center of gravity of the combined object from point X is. Right, let's do this, something like this. See, what I can see is these two. Look at here. These two, B and C, these two are identical, no? Since these two are identical, their center of gravity should be at their symmetric center, at their symmetric point. About B and C. Right? About B and C. Are they wires? Yeah, they are wires. Rings. Rings means wires. Huh? Rings are considered as wires. Rings are considered as wires. Rings are considered as wires. Wires, ne? Rings are considered as wires. Right? Wires. Wires now, we are considering length when you are writing weight. You are considering length when you are writing weight. Right? Then radius 2R. 2R. Then let me use this color here. Then this is 2 phi R, which means 2 phi 2R rho G, something like this. Then 2 phi 2R rho G. From this 2 phi and rho G are common, no? Don't write it. 2 phi and rho G are common. In each and every ring, 2 phi and rho G are common. Variable is 2R. Then let's stick to variable. This is 2R. Then from this point also, 2R acts. Then it's resultant 4R acts here, 4R acts here. So let's label this as G1. That is the center of gravity of those two. Now, I'm going to find the center of gravity of remaining two now. D and A. DA wala hoga. Center of gravity of D should be at 3R from here, no? Somewhere here. What happened? Center of gravity of, see, center of gravity of D should be here, no? From 3r, its radius is 3r, it says. Then this variable is 3r, and center of gravity of this small one should be here, that is r. Forces. Then let's find center of gravity of these two. Let's assume that this as G2. Look at the diagram. Let's assume that as G2. And if we find center of gravity of these two from this center of gravity, r and 3r means 4r. The resultant of 4r should act. Right. So let's find distance to that center of gravity from here. Say that is x. Apply a force dividing ratio. X equals total distance in between is from this small circle. This is kind of critical. From this small circle, this is r. This is r, no? This is r. Then up to this point, we know this is 3r, which means this whole part should be, up to here we know this is 3r. This is only r. If r is removed, then this whole part is 2r, no? Then total is 2r. Clear, no? Total is 2r over resultant is 4r into not connected force. I need x, then the not connected one is 3r. That is 3r. Then r to r cancels. Then it says x equals, and 2 to this one cancels, no? 3r over 2. It says x equals 3r over 2. X equals 3r over 2. Right. X equals 3r over 2. Now, what is remaining in my system? Now, I'm going to erase this part. Now, what is remaining in my system? This is a kind of a good calculation. Right. Now, what is remaining is, right, on this line. Now, on this line, here we have 4r. Here we have 4r. And this part is r plus x. Then what is r plus x? R plus x being 3r over 2 plus r, no? 5r over 2. Then 5r over distance, 5r over 2 distance from here. Distance this part, right? Then 5r over 2 from here at this point, another 4r, this one next, no? Then center of gravity of these two must be at the center of these two, right? Because they are 4r and 4r. This is a good one. They are 4r and 4r. Then they should be at the center of these two. Then 5r over 2 over 2. Then 5r over 2 over 2 means 5r over 4. See, that's a good one. 5r over 4. That's a good one. Good calculation after a while. 5r over 4. Right? Next, when a plate PQRST is hanging freely from point X, it balances as shown in figure 1. When hanging freely from point Y, it balances as shown in figure 2. The center of gravity of the plate is most likely grounded. Same thing we did. Right? If you are given two scenarios, identify their vertical lines. So on the vertical line, we know on the vertical line, there should be center of gravity which connects this. Then from S, it is 4 grids from here, no? From S, 4 grids. So this is the line which comes from the first one, and this is the line which comes from the second one, right? It's close to B, right? Close to B. Simple. Close to B. 25. A triangular shaped portion QBR. QBR can make a triangular shaped portion QBR is removed from a uniform square sheet PQRS. Is removed from a uniform square sheet PQRS. This one from PQRS and connected to form a composite sheet. Okay, this removed part is connected to here. You got it, right? That removed part is connected to there. Okay, then let's remove these workings, right? Okay, then mass is distributed only in this region, no, this area, no, and this part. This is the part with mass distribution, right? This part. The center of gravity of the sheet is, right? Now, Listen, when it is as a square like this, center of gravity is at the center. When it is as a square, then center of gravity should be at B. If that was the square, should be at B. Now, this removed part is added to this side. Added to this side, then it should be shifting to the right side. Should be shifting to the right side. Right? Shifting to the right side. Shifting to the right side. But it cannot be shifted as close as to D because only a triangular part is like 1/4 of the mass is removed. Right? Still 1/3 is this side. Still 1/3 of the mass is here. Sorry, 1/3, 3/4 of the mass is here. Right? Still 3/4 of the mass is here and only 1/4 of the mass is here. So it should be close to this side. Right? Should be close to this side. Then should be C. Should be C. Right? That's all. That's all. See, that's how center of gravity is done. Goda Kamar Padman, this is not a difficult lesson, right? Difficult lesson, not a difficult lesson, right? This is a lesson with like very few theories, few theory parts, and a small lesson, and very much manageable lesson, and you are getting a definite question here, right? Any questions? You can ask if there's anything to clarify. Anything? Anything from how many MCQs? 25. We have discussed 25 MCQs now. We have discussed 25 MCQs today. Any questions from these 25 MCQs we discussed? Is it all clear? All clear? Or any questions from these 25 MCQs of center of gravity we discussed? Then let me stop sharing. Right. Okay then. Okay, right. All right, listen. So we have come to the end of the 7th day of S2A as well, and we have finished center of gravity today. Practice these questions again. Practice these questions again. Center of gravity is 1 mark that you can secure from 50 marks, right? 1 out of 50 that you can secure if you are comfortable with these things, right? This is not as hard as other lessons. I mean, other parts of mechanics, a very manageable part and a definite question. So don't miss it. And the good news is you are 23 weeks and 2 days ahead of the exam now, right? The good news is you are 23 weeks and 2 days ahead of the exam now, right? So don't waste the time. Don't waste even a second of your time you have now. 26 students. This is for 26 batch, right? So utilize your time without wasting, right? Okay. Then I will update you the next lesson that we are going to discuss in this way in channels, right? Then if no questions, we'll wind up. Practice questions, work hard, study hard, right? And stay safe, right? See you in the next class. Good night and goodbye. See you.